Okay, so here we have an example of a ride at a theme park. So a person strapped in, attached to stretched bungee cords, and we are asked to identify which energy store increases as the bungee cords are stretched. So when you are stretching or squashing anything, that is the elastic potential energy. So it is the elastic potential energy store. Okay, so we're told that the pod is released and it's accelerating upwards. Before the pod is released, the extension of each of the two bungee cords is 8 meters. We're told that we've got a spring constant of 735 newtons per meter. We've got the mass of the pod of 240, and we've got the gravitational field strength. We are asked to calculate the maximum height. So as you can see, this is 6 marks. It's quite a lengthy multi-step calculation. So what this is relying on here is looking at the transfer of energy that is taking place. So we have an elastic energy store that is then being converted into a gravitational potential energy store. So whilst the bungee cord is at the bottom, we've got the elastic store building up. And then when it is released, we assume that all of that elastic energy is transferred into gravitational energy. So therefore, if we look at the fact that we might be able to calculate the elastic energy, so the elastic energy from our formula sheet is half k E squared. Okay, so if you look at that, we've got each bungee cord, we've got an E there of 8 meters. The 735 is our K. So we are able to calculate the elastic energy that is transferred. So we could do half times by 735 times by 8 squared. Okay, that then gives an elastic energy of 23,520 joules. Now remember, that is in one cord only. So we are told in the question that each of the two bungee cords extends by 8 meters, and therefore the total elastic energy that we've got is actually 2 times that. So 2 lots of 23520 joules, and that has a value of 47,040 joules. So that is the elastic energy that we have in the bungee cords. So now we're going to assume that all of that elastic energy gets converted into gravitational potential energy. Okay, and we know from our formula sheet that gravitational potential energy is mgh. So we can now say, okay, well, that 47040 is equal to the mass, which we've got, which is 240 kilograms, multiplied by g, which we're told is 9.8, multiplied by h, and h is the maximum height that is going to be reached by the pod. So we now need to rearrange that to make h the subject. So h is currently multiplied by 240 and by 9.8. So to leave h on its own, we divide both sides by 240 times 9.8. So we have 47040 divided by 240 times 9.8, and that will give us our maximum height, and that gives us a value of 20 meters. But we're then told that the maximum height is actually going to be lower than this. So we did say earlier on that we were assuming that all of that elastic energy got converted into gravitational energy. But of course, we know that there are always going to be energy losses when we get a transfer taking place. Now, the reason for energy losses in this situation is down to air resistance. Okay, so there will be air resistance, a force working against the pod. Okay, so as that pod moves upwards, it's going to experience air resistance acting against it. And what that means is that not all the elastic energy is actually going to get converted.